Today we're going to be looking at Datagram3D, a new software out of Israel manufactured by Datumate Limited. Datagram3D is a unique software that allows you to draw polylines, points, and areas directly on photographs that have been anchored down with control. This software allows you to use virtually any camera and any PC to do the work. However, there are some things we recommend. First, as far as computer goes, we would recommend that you use a Windows 7 or a Windows 8 operating system with a minimum of 8 gigabytes of RAM. People have used 4 and even 6 gigs of RAM and it will work, but again, our recommendation is 8 gigs of RAM, Windows 7 or 8 operating system, and a 64-bit machine. Your hard drive should be big enough in order to handle the amount of photographs that you're going to be using. Camera-wise, again, almost any camera will work in the field. However, there are a couple of things that, again, we strongly recommend. One is that it's an 18 to 20 megapixel camera. As you're going to see when we start looking at the software, the megapixels will make a difference as to how tight of an accuracy you can get when drawing your polylines and points. We also recommend that there be a fixed focus. No focus where you can adjust zoom in, zoom out. That will not work. When you calibrate the camera, it has to be at one level only. So the best recommendation there is a wide-angled lensed camera, somewhere between 12 and 18 millimeters on the wide angle. You can get most of these. We're going to be using a Samsung NX2000 with a 16 millimeter fixed lens in our demonstration. It was about $450 at one of the local box stores. As far as job site control goes, it's a little bit different than your normal control in that we're going to be using building corners, window corners, telephone poles, paint stripes, that type of thing, in order to anchor down our photographs. You can use special targets such as checkerboards and that type of thing if you choose, but it's not necessary. So let's dig into a little bit about, you're going to see in this image here that what we want to do is shoot the site with a camera, anchor it with a total station, and then begin drawing our points. When we talk about shooting our photographs, there's a few things that we need to remember. The first thing is that Datumate works off of angles. Angles, angles, angles. Very, very important that you get varying angles in your point of interest. You can see here by this little illustration that we're basically shooting this at 90-degree angles with a center point coming in. We can then go ahead and pick redundant points up. We can even do things like we're going to show you in the project we're going to work on, where we put the camera on top of a 15-foot prism pole. The Samsung NX2000 that we use allows us with a little application to run it off of our iPhone or Android phones so that we can see what we're shooting. We click, we shoot, and we move on. In this case of this little illustration here, we're just concentrating on this one side of the building really. We would want to repeat the same photographic from every side of the building in order to get a complete surrounding. We can move in, out, up, down, and we actually want to do that. We want to move in and out of the photograph. We want to raise and lower our camera. All of these things help with the angles that we're trying to achieve to get us the best possible points. When we start taking image reflectorless shots with our total station, or we could use GPS shots, but remember that the accuracy and precision of your polylines are going to be dependent upon how tight your control shots or your anchor points are. So when we shoot these points, what we want to do is we want to be able to pick repeatable objects, like the very top of this building corner, like the very edge or bottom corner of this sign. This here represents a little quick stake that we put in the ground that we can shoot. We want our geometry to be very good as well. Think of like a localization or a resection. We want to kind of cube our whole site in, front, back, top, bottom, so that we can kind of get a full surrounding of what it is that we're trying to shoot. This is very important and can take some practice. Sometimes one of the best things to do is after taking your photos, go back to the office if the project allows, print the photos out, Then circle in the photos what you think would be good control points. These can then be taken back out with the total station with your survey crews and shot, brought back in the office, and used. That brings me to another point. When shooting your anchor or control points, make sure you document very, very well what you shot. The best way we found to do this is with a little sketch. On that sketch, you just label each point that you shot. Let me go back to the photos for a moment, because one other thing. Taking a photo takes about 2 seconds. We highly recommend that you take way more photos than you need. Triple, quadruple the amount that you think you might need. Take photos, 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 photos. And if possible and convenient, take as many anchor points as you can as well. You may not and probably will not use all of them, but it's better to have them and not need them than to need them and not have them. Let's go ahead and dive into the Datumate software. The first thing we need to do when working with the Datumate is calibrate our camera. This process has to be done once and only once for each camera. I've got cameras in here, but let me show you briefly how this is done. We go to our Tools drop-down and we choose Calibrate. We then enter a name for the camera we're going to calibrate. They give you an example down here of what they suggest. So we're just going to call this Samsung NX2000. We cannot use spaces. We need to use underlines for things. And then we can go ahead and put in whatever other information we might want about the camera, like the date, that type of thing. We then go ahead and go to our next step, Start. Now here, at this point, you want to print out one of these checkerboard patterns. You recommend you send it to a plotter and you hit your print button. It opens it up and you can go ahead and print this out. Once it's printed out, what you want to do is take a measurement from the very top corner of the black checkerboard to the very side corner of the checkerboard, and then again from the top to the bottom. You're going to want to write these measurements down because you're going to need them in your next step. So the next step is to go ahead and put those measurements in. In my case, the width of my checkerboard was 27 inches by 21.18 inches. The columns and the rows should be right if you printed the A30 checkerboard, which we did. The next step is telling you how to take your photographs. Now this is important because the first few times I tried to calibrate a camera, I failed. What you want to do is set your checkerboard on the floor and then stand in one position with your camera. You may need to kneel if it's on the floor at a 45-degree angle roughly from it. You can be up a little higher, down a little bit lower, but try to be within 5 degrees plus or minus of that 45-degree angle. Staying in that same position then, you will take one photo with the camera horizontal. You will rotate the camera about 45 degrees to the left, still in the same position, just rotating your camera, and take a second photo. You'll then go to a 90 degree, take a third photo, and I recommend going also to the right 45 degrees and taking a fourth photo. You can take as many as you want, but usually 4 photos has been what I found to be best. The next step is to go ahead and load those calibration images. So let's go ahead and pick that. I've saved all of my stuff in 3 folders under Sharon Church on the desktop. I have my control points, which are an ASCII file. I have my photographs from the job site, and I have my calibration photos. Again, you only need to do this calibration routine once. Once it's done, you will not need to do it again. Here now it's going to go ahead and load the calibration, and I'll show you how we go ahead to our next step. So it tells us what to do. It tells us to pick the circles in the images. You'll see here in these photos that I kind of cheated and I just took the photos off of my computer, which is not the best or most accurate way to do it. But for the purpose of this demonstration, we'll show you how it's done. And so what I'm doing is I'm just clicking once on each photo and then making sure it picked the black circle from my target. You also want to make sure that in each photo you have all the checkerboard shown. Okay, you can't have it cut off in any way. So once that's done, you simply click your next button and the system will go through and try to calibrate. I expect at this point, because of the way I took the photos, for this to fail. And what we're going to see is a red circle come up that'll tell us that it failed. In the case that it worked, we would see a green circle come up telling us that we have an acceptable calibration. Okay, as expected, the calibration failed, and so we would want to go back and redo our calibration. I already have one done for this camera, so for the purpose of this demonstration, we're going to go ahead and use that one that I already have. So once our calibration is in there, the next step is to go ahead and load our images. Well, I'm sorry, back up. The next step is to create a new job. So we're going to go ahead and go to New Job, and we're going to create that job. Again, the structure is a little finicky in that you can't put spaces in the job name, that type of thing, but we can go ahead and create our job, and then it tells us to load our images. So I hit Load Images, I go to my folder where my photographs are found, and I start selecting images. Now this is where it takes a little bit of work in order to decide what you want to shoot. What we can do to help us pick the photos is we can right click and choose Preview, and that shows us a wider picture of our photos that we have to pick from. You can see here what we're doing is the front side of an old church building. We're just going to scroll through a little bit, and these are some photos of the adjoining property. We probably will not use them, but as I said, I'd rather take more pictures than less. So I'm just kind of scrolling through from this angle. I want to see what I have that I might or might not use. And so I roll through my pictures and choose a photograph that I think I want to use. And I'm going to go ahead and use this number 0808. So let me exit that and pick 0808, which is that one there. And what I'm looking for is I've got a photograph that's far back, but I've got about a 400-foot range with this particular camera, and it shows me a lot of the profile of the site. This one over here also looks good, so I'm going to hold my control button down and select that. And then right next to it, I've got from another angle, and I'll show you what I'm looking for more in just a moment. So I've selected 3 photographs to start, and I recommend that you only do about 3 for your very first project and for starting the job. And you can see a little bit better in these thumbnails now. I'm from the right angle, center on, and from the left angle. Now I have to select my camera calibration, and so I'm going to go ahead and select the camera that I'm using in this calibration and say next. You'll see here that it stores all the different cameras that you've used. We'll say next. Now it pops up and asks me to import my control points. So let's go ahead and look at our control file. What you'll see when I do that when I go ahead and open up my control file and a notepad is that it's point number, northing, easting, elevation, and no description. The software does not like the description field, so make sure that you have that taken off of the file before opening it up in Datumate 3D. So we're going to go ahead and hit import here. And I want you to pay very close attention to the bottom dialog on this right-hand side. At default is East, Northern, Zenith. We want to be NEZ in our system. So what we're going to do is go ahead, go to our control, and just say open it. It now shows up on the left-hand side. Our software then tells us what we want to do, and we want to start marking our control points. So I have my surveyor's drawings to my left side here, and what I'm going to do is go ahead and start zooming in and picking the control points. On the left hand side you see we have an arrow and we have a control point marker. I'm going to use the ruler ball on my mouse to go ahead and zoom in, and then I'm going to use the right key by holding it down to pan. I know my surveyor reflectively shot this top point, so I'm just going to go ahead and select that, and we're going to label it accordingly. In their case, it's 10,023. So after we've labeled the first control point, you'll see that down in our bottom here, it shows up as number 1, meaning one control point has been found. We can then go ahead and go through our drawing and continue to search for different points that we can grab and locate as control points in this job site. I know, for example, that I also have on this top corner of the window here, right over here, we have another control point that I can click, 10,028 according to my surveyor's drawing. That drawing is very important because without it I wouldn't know how to necessarily pick the different things that are located. Let's see what else we can find here. So far everything we're doing is linear, which in my mind makes this not a perfect way of calibrating the site, but we're going to go ahead because it's what we have to work with and continue to work this way. Up here we have 10,022. We label that, and when we do, you see down here it's telling us we've labeled 3 points in this, and we need a minimum of 4 control points in each image. So my last control point in this particular file is going to be right in this corner here, and that one is going to be 10,279. And we're going to move on to our next photo. I'm going to go ahead and repeat this procedure in all the photos, and we'll join you back in a moment. So in my second photograph, I now have 4 points that I've located. The points do not have to be the same from photo to photo. They can be any different points. Ideally, on this job site, I would have liked to have had some points shot over here, maybe something over here if we could have located on the sign out front here, some different things that would have brought the site in a little bit better. But given what I was given by the survey crew, this is what I have to work with. Now again, ideally, maybe we would have printed out some of these photos, circled what we wanted, and sent them back to the crew, and they could have went in the field. But we're going to continue to work with what we have. For example, we know that we have some points here. I know I have this top fence rail, so I'll go ahead and locate these as well. So now I've gone ahead in my third photograph and I've located 4 points, 1 on the fence post, then 3 on the building. Again, and ideally I would have had some points maybe out here in the road, maybe I would have had something over here on this little building, and that would have really tied down my site a lot more. But after we've gotten our 4 points, as you can tell by the photos on the bottom here, in each photograph, I can go ahead and run my quality check. What we're looking for now is to see a green bubble show up here, which we've done. And then as an extra check, I like to go through and see that my CQ on all of my control points is good. I've got reds here, which tell me that there are some issues. So even though I have a green go light up here, I want to go ahead and go through and address some of these bad, if you want to call it, points. Now these numbers that we're seeing here are pixels. These numbers are not in tenths and hundredths or in feet or in metric. These are pixels. These are how many pixels point 10,023 is off. So by double clicking, I can go ahead and see where 10,023 is, and I can zoom into it and tell whether or not I just didn't pick accurately, which is probably the case. I can then go ahead and move that up a little bit and rerun my quality check. When I do that, in this case, it got a little bit worse. And now my light has gone to red. So there's something not quite right there. And what I want to do in order to look at that is let's just go back through some of these different points. I'm going to turn on my projections and my names. I'm going to select Edit and say Select All. What this does now is it puts little markers where it thinks that point ought to be. And you can tell by this, we've got some kind of a large horizontal error because it thinks it's over here. We know it's on this end. So there's some problem in one of these photographs somewhere with one of my control points. And what we need to do is find it. So let's start by looking at our largest errors and see what we can figure out. You can see the point, it can become quite congested when I have everything turned on. So we're going to go ahead and scroll in, see what we've got going on here. It's suggesting that it's up there. You can see from what I've done that I'm off some here. I can move back out. I can rerun the quality check. It reruns it and tells me the situation. Let's go back down and look at some of our other points. 23 is still way off. We know that. Let's look at 28. It may be that I have just got a bad location from my surveying information. Yes, 28 right here is actually supposed to be on this side of the window. So I picked the wrong point. And so we're going to go ahead and run the quality check now. Now we get green, and you can see all of my control looks much better. And if we go back up to this one here before, which had it way over to the right, I can see from my projections now that the point is much closer and much more real to where it should be. So the whole purpose of looking at these projections, and we can turn their names back on, is to get a really good idea as to where things are supposed to be and how well they worked. At this point, I have 3 successfully registered photographs. I could go ahead and try to start drawing my line work. And anything that showed up in these 3 photographs would probably work. But because the system works on angles, and again, more angles, the best thing I can do for myself is to go ahead and load more photos. The more times the points you're trying to collect show in the photos, the more accurate your coordinate quality of each of those will be. So we're going to go ahead and load more photos. But before I do that, I want to show you what just happened with our control. I told you over here we were looking at the accuracy of it in pixels. Let's go to Report tab. Now we can see the accuracy of it in US feet. And if I click on the columns, I can sort them. So you can see my x-axis, the worst I had there was 9 thousandths. My y, 3 thousandths. And my height was 12 thousandths. So I've got very, very good residuals on the quality of the anchoring of my points. Let's go ahead and go back to images, and let's go ahead and load more images. Now I could tell from those photographs that the pictures I took were all from ground level. So I'm going to go ahead and go into my photographs. I know near the end of the job I started taking some of the points from up on a 15-foot pole. And I'm going to go ahead and open up this last one here. Let's actually use this one over here. We're going to go ahead and open that up. And what I'm looking at is just a different angle and a different way of taking the photo. This actually looks to me like it is a ground level also, so I really don't want to use it. I'm going to delete it by right-clicking on it. And let's see here. Let's see if I can get something that was up in the air on that corner. This one looks pretty interesting here. Looks like it might be an upward shot. Or perhaps not. Let's keep scrolling down here, and just what I'm trying to do again is just find different perspectives to work from. I want more angles, and the more angles I have, and this one you can tell I'm way up in the air, I'm looking down, so this one will be a nice one to work on. So again, we just say next. It takes us to our control points. You can see we've got 4, 4, 4, and then we've got none in this last photo. So once we click on it, we lost our green light, we lost our quality because it needs to be there. In this photo, I can see down at the bottom here, our surveyor actually put this little red marker on the windows. So I'm going to go ahead and select that. And this red marker was number 1. I'm going to zoom out. He's got a red marker also on this window here, which was number 3. And the reason I didn't have these red markers in my earlier photos was because I took them before the surveyors had gotten an opportunity to place them. So that's something else you're going to want to watch, is when you take the photos will make a difference, and what is in the photos versus what the surveyors are shooting versus the data that you want. Down here I know the top of this fence pole, and so I want to go ahead and grab that, and that particular shot is 10,030. So once again, I have 4 photos shot, and I pulled this one out here because I want to get away. Again, ideally I'd have something over here, I'd maybe have something up here, maybe even something on the road. But we're going to go ahead and run the quality with this, and you'll see once again I got a green light and I've got a 4th image in there. So I'm going to go ahead now and load a few more images and repeat this process on those images. Okay, as I've been working, I've been getting reds here, and I believe it's because this point is a wrong point. So what I'm simply going to do is go ahead and click on it, right click on it that is, and tell it to delete it. When I do, I have some options here where I can delete the point from the entire job, which I do not want to do. I can delete the marker from all images, or in this case, I want to delete the mark from this image only. This will be what you use most often and ask you if you're sure, and you say yes. So once I've done that, I can go ahead and run my quality check again, and you'll see I've got a yellow solution here, and it's because I've got one point that is off. While I'm looking at this point, and I zoom in, it's very hard to see any contrast on this window marker. And it's telling me that it's up high, which I can believe because of the reflectorless total station, but I'm not quite confident enough to trust it. So I'm going to delete that as well. And I'm going to find something that I feel a little bit better about. Let's go ahead and find this top left corner, which I know where that one is. We're going to go ahead and mark that 10028. Okay, run quality control and see how we do. We've got green. So there gives you a little bit of an idea as to how I can manipulate and move some of the images in order to make sure some of the markers that I get the right photos. I can also come up here and check. That looks very believable with the reflectorless, that's where they would have shot. The same up there, again, depending upon the angle where they're shooting from. So I'm going to continue loading photos at this point. So now I've gone ahead and I've anchored a total of 8 photographs down at this point, which I think is going to be pretty good to start drawing. You'll see here as I go through them that I have them from different perspectives on the job site. Again, what I'm looking at is different angles that I can create into the same structure. That way it gives me a little bit better opportunity to get high quality polylines, points, and areas closed down at the end. So once I've done this, I'm ready to go ahead, and you can see by my quality here, I'm pretty good on everything I've done. Oh, I've got one mistake here, so let's go ahead and look at 1028 here and see what the deal is. If I go ahead and turn my projections on, you can see I'm a little lower than what it would have expected, so I can go ahead and address that. Make a little bit of adjustment to it, and it helps fix it out. So you can see though overall we're in really good shape. So we're going to go ahead and go to our new points tab now, and what we have here now is a drop down menu on the right hand side, and what this does is allows me to draw a point here, draw a polyline here, draw a closed area here, and measure between any 2 point nodes that I have. On the right hand side we can create layers, so I can give myself a layer name here of building, let's say. I can also assign that layer a particular color that I might want to use for that layer. And versions coming forward, we're going to have the ability to actually import your AutoCAD layers as well. Down here it's going to show the different objects that I collect when I do. So let's go ahead and grab our point button here and grab a photograph we might want to work from, let's say the front face of the building, and we're going to go ahead and just very simply come in. Let's actually do a closed polygon, and we're going to come into this window here, and we're going to go ahead and just draw around the window. We're going to start at the bottom of the eave here. It's asking us for a name, so we might want to call this Polygon 100. We could put a code and a description in there, window, whatever we wanted to call it. And we've got our first node point. I'm going to go ahead and scroll over, and I'm not going to take a tremendous amount of time doing this. I'm just going to get them pretty close right now. You'll see on the right side what it's trying to do is find that node in many different photos. If it does, it'll turn my little nodes green once it finds enough of them in the different photos. So we're going to click that bottom, and we're going to double click over here now to close the polygon. Okay, so what it's doing is, again, it's searching through the different photos to find out if it can reference it through 3 or more photographs. The fact that it turned gray is telling me that it did not find those points in 3 photos with its auto function. Now I started up in the right hand, it was P101, P102, 3, and 4 is my closing. So what I can do to help the software now, because I know those points show up in different photographs, is I can click on another photo where those points might be. I can come in and scroll in. I can now pick my point. I can click on it, tell it's an existing point, not a new point. And when I pick existing, I can then pick 101 from the list. I can repeat that now for my other points. You'll see that that turned green over there now, telling me that with that little bit of help I just gave it, it was able to find it in 3 other photographs. And once it's done that, then we can start to look at an XYZ quality. So let's go ahead and pick our last one here. And now those 2 are yellow, meaning that it only found it in 2. It hasn't quite found it in 3 yet. But because it's yellow, when we go to our approve section, it will give us some suggestions. So we've gone ahead and we've located these points. We come to approve, and what we're looking for is sub-centimeter level accuracy out of this data. You can see my data is being shown to me in feet, so I'd like to see something under a tenth, under 6, 700ths, if not better. And you can see my data is not of that quality yet. So with the P100 on, this is the 4th point that it only found in 2 photographs. It shows me other places where it might be. Right here, we know, for example, it is. If I click in that and I zoom out with my roller ball, I verify that's where it is. I can then zoom in and put my crosshair on where that point belongs. I click there. It now turned green because it's in 3 photos, and I can repeat the process over here to verify and help it find in the photos those different points. You'll see my accuracies up here are getting much better as I go. So let's click this last 2 here and see, yep, that's right. Now here we don't have a lot of contrast between the whites, so it might be why it did not automatically find it in that photograph. Same thing here. Let's click that, and now you'll see we have an X of 300ths, a Y of 400ths, and a Z of 500ths. I can tighten that up simply by going into each of my photos and just taking a little bit more time with my picks. And you'll see my accuracies are getting a little bit better as I go. And as I'm providing redundancy for the software to be able to say, yep, that's the point. Okay, so it looks like that's about the best I'm going to get on that particular one. Now I need to repeat the process here, and once you get rolling on this, it becomes a pretty quick process to do. And you'll see my data is getting better and better as I go, and the more points I add to the software. So I can just repeat these throughout all my different photographs here. Making sure that I make the best attempts to pick accurately on my photos. And I can zoom in and out with my roller ball to get better and better at my points. So what we're doing is, literally after anchoring those photos down, and when I was offline with you, I spent maybe 15 minutes anchoring those additional photos. And that photo, it looks like maybe down here is our bottom window. Yep. And that actually made it worse. So what we can do is we can just exit that and it will get rid of that photo for us. So see here, by the more photographs I brought in, and I had more photos with this image, I could have gotten a tighter and tighter position. My angles made all the difference in the world when collecting these points, because the more images I have that in, the better. I can continue with that same process, repeating it over and over again, looking for things like building corners, etc. Let's go ahead and just put a point right up there, call it a new point. We'll call it PT1000, and we can code it however we want to code it and continue with our process. It's going to go through, it's going to try to auto find that point, and you can see it doing it over here, but it still stayed gray, so it's not quite sure. And so what I'm going to have to do again is go into my photograph, look for that point, click on it, existing point, PT1000, okay. The software now went through all the photos, it found it. We go to our approved section, we're looking at PT1000, and it found it very well. Our accuracies are good on it. We can go ahead and add more to it to help it a little bit more. And you'll see we got some very good accuracies off that point in just a few moments. Once we've collected all the data from the drawings that we want, we come to our report tab. Here we have our accuracies listed for us. We have a couple of different options we can do now. One of the things I like to do, and it's a pretty simple thing, is just to highlight all of my points. I hold my control button down and then hit the letter C. Control C is copy in Windows. I can then minimize that. I can open up Microsoft Excel, and I can hit Control and V for paste, or I can go to my Edit tab and paste. Whoops. I must not have gotten my data. Let me look at that again here and come back. Highlight it, Control C, and Control V to paste. And you'll see real quickly there I get a little report for me of my coordinates and all the accuracies associated with those coordinates. That's one way to do it. There's several other ways that we can do it within the software itself. We can actually view a report, and when we do that, what it's going to do is pull up a Datagram3D report, and it's going to show me all of our information with our residuals, our sigmas, all that type of stuff of what we've done. I can also go ahead and export this as an XYZ coordinate file, and we're just going to go ahead and put it on our desktop here. And once I've done that, I can then go ahead and do File, Open, and go to my desktop, show all files, open that PNT file. It's a delimited file, and it's space delimited. Finish it, and there's my coordinate file for myself again. And the final way that I can do this, if I had been collecting line work, which I did on my window there, is I can export a DXF. Once I export a DXF, I can then take that export, the DXF, and I can open it in pretty much any CAD program that exists. And so I'm going to go ahead and open Carlson survey on IntelliCAD as opposed to on AutoCAD. And we're going to go ahead and just open up our little DXF, test DXF that we just saved there. And when we do, you'll see it comes in, and unfortunately because the line work was on a vertical plane, I'd have to rotate this up vertically, which is a lot easier to do with AutoCAD than IntelliCAD, but you're going to still see the data when we go ahead and bring that in there. In Carlson, once it's in there, we got a zoom extents. So we'll zoom extents, and in here is our data. All of our points came in, and there's our window polyline again. We're looking at it from the top down, but all that data is there, and we can very simply see it. We can click on any of our points here and see that it is a 3D point. And all your data is in a DXF format brought directly into CAD. Well, I hope that helps you understand a little bit more about the Datagram3D and the process that would be used to create the data. One last thing before I forget, I kind of skipped over this in the beginning, but Datumate, when you get it out of the box, comes in set up in centimeters. So in order to set it up in feet, we need to go to settings and simply change our measurement units here to US feet. If you have any questions, please feel free to contact eGPS Solutions. I'll put the information below, along with a link to a little paper that we've written that goes over some of the process involved in how to collect your photographs and how to do your control points. Thanks for watching, and have a good day.